Introducing the ARM architecture. In this lecture, you're going to learn about the ARM architecture and its feature. So let's take a look at this picture that is about ARM-based processor in the silicon chip. So this picture comes from a foundry that is to manufacture the own chipset from the various chipset vendors like Qualcomm, MediaTek, and NVIDIA. But this silicon is nothing but the chipset, so it is hard to control the chipset using the software stack. So from the software perspective, then we need the interface to control those kind of ARM-based chipset IP and using assembly instruction or register. So from the software perspective, then we have the ARM architecture. With the viewpoint ARM architecture, this silicon chip can be controllable using the set of the instruction and using the relevant register. The software point of view of the ARM-based silicon chip is the ARM architecture. So many of the system and software developer wanted to learn about the ARM architecture instead of how to design this ARM-based processor in the silicon chip. So what is ARM architecture? The ARM architecture include the various features that will be explored in the next slide. Now let's look at the features of the ARM version 8 architecture. The first feature of the ARM version 8 architecture is assembly instruction. We call assembly instruction as the instruction set architecture. In the traditional terminology, we call architecture of CPU processor is called instruction set architecture. Another feature is register. In the ARM version 8 architecture, there are 4 types of register that include general purpose register and the special register and P-state or SPSR-EL1 register and system register. Another important feature is exception. So in the ARM version 8 architecture, the program counter jump to the exception vector address when exception occurs. The main cause of exception is memory abort, and another cause of exception is when the peripheral device the fire or trigger interrupt. Another feature is the calling convention in ARM architecture. If you wanted to call the particular function in your code, the ARM architecture supports the calling convention. The calling convention specifies how the argument is passed using the particular register, how the return value can be stored using the specific register. Those kind of standard is called the AAPCS. Another important feature is virtualization. Especially in automotive sector, hypervisor is the main software stack to run or manage the various guest OS. To make it possible, ARM version 8 architecture should support virtualization. Virtualization supports implementation of exception level 2, where hypervisor is running at the exception level. Another key feature is the MMU. We call this kind of feature as the virtual memory system. In the virtual memory system, we need to learn about the multi-level, the page table, and the translation look aside buffer. And another thing we have to understand is how the virtual address can be translated into the physical address. But there are more the features in the ARM version 8 architecture. Now, we just highlight the primary feature of ARM version 8 architecture. With the feature, we can control ARM processor from software perspective. Another important thing we have to remember is that in the software world, we can only think about the architecture. Architecture means the viewpoint of software to control ARM processor. But when you look at the actual product line of ARM processor, you can see a Cortex-A 35 processor, Cortex-A 53 processor, or this the product line is included in A profile, the ARM processor. Important point is all these ARM processor can be included in ARM version 8 architecture. From the software perspective, the assembly instruction and register, all these kind of the features can be comparable across the multiple ARM processor. Let's suppose that you actually implement your own the assembly instruction that could be runnable in Cortex-A53 processor. So for this, you implement your own the assembly block using this ARM version 8 based compiler, and all of the features of assembly instruction register is based on ARM version 8 architecture. Important point is this assembly routine can be executable in another Cortex processor, such as Cortex-A73 and Cortex-A78, because all these product line of ARM processor share the one architecture, that is ARM version 8 architecture. So from software perspective, as system software engineer, important point to the check is the version of the ARM architecture. If you first review the specification of your project, the first thing you have to check is the version of the ARM architecture. The next thing you have to do is to check the specification of the product line of the ARM processor. Another important thing is, in between several ARM processor, the actual implementation of the MMU and cache and the multi-level cache may be different, because those kinds of the features can be implemented in the microarchitecture level. Microarchitecture level means that some sort of this implementation is based on hardware. But if you look at the ARM architecture perspective, we only think about this kind of feature. Now that you got to know about the feature of the ARM architecture, let's explore product line of ARM version 7 8 architecture and ARM version 8 architecture in the next lecture.